Yesterday we talked about Venn diagrams. We did that kind of setup so that we could solve some probability. Today we're going to talk about a sample space diagram. We talked about sample spaces on Monday, so all the different outcomes that could happen. But now we're going to actually write all those out so that we can see them and go from there. By the way, I looked at all the stuff for the unit, and I'm going to bump that test next Wednesday is what I'm going to do, okay? And so we will most likely have like a quiz on Tuesday, and we'll review and stuff on Tuesday, but we'll bump that test on Wednesday, all right? So I think that'll be fine for us, stuff as well, okay? All right, here we go. So here's the problem on this one. We've got this little spinner over here, and we're going to spin it. It's got the numbers 1, 2, and 3 on it. We're going to spin it 3 times, and we're going to list all the possible outcomes there, all right? How many outcomes would I have if I spin this 3 times? 9. We're getting close. 3, 9, 27. It's going to be 27. Okay? Why? Because if I were to do this, on the first spin, how many outcomes do I have for the first spin? 3. How many outcomes do I have for the second spin? 3. How many for the third spin? 3. So 3 times 3 times 3. That's that counting principle that we talked about on Monday. I can get 27 different things. All right? Now, on this, let's go in and read what we're going to do with this. That way you'll understand while we're doing this. It says, find all the possibilities. We're going to do that here in a second. But it says, after you do this, hence, find the probability that the score on the last spin is greater than the score on the first 2 spins. Okay? Well, that's kind of difficult. I can't really just envision that. I probably need to see that written out so that I can go find all the different ways. Okay? So I'm going to start. So in my first little column over here, I'm going to say, okay, what if I were to roll a 1 on all 3 spins? So I got a 1, 1, 1. I went 1, 1, 2 could be another outcome. And 1, 1, 3. So I'm kind of trying to do this systematically as I'm going. Now I'm going to keep the 1 in the front. I'm going to change the middle number to a 2. So 1, 2, 1, 1, 2, 2, 1, 2, 3. And then I'm going to change that middle number to a 3. So 1, 3, 1, 1, 3, 2, 1, 3, 3. Okay? So I've listed 9 of my outcomes so far. Okay? How are my next 2 columns going to change? I'm just going to change the first number, right? Everything else is going to look the same. I'm just going to change the first number. So my next column is going to be 2, 1, 1, 2, 1, 2, 2, 1, 3, 2, 2, 1, 2, 2, 2, 2, 2, 3, 3, 2, 1, or not 3, sorry, got ahead of myself. All right, 2, 3, 1, 2, 3, 2, and 2, 3, 3. All right, and then the last one, 3, 1, 1, 3, 1, 2, 3, 1, 3, 3, 2, 1, 3, 2, 2, 3, 2, 3, and 3, 3, 1, 3, 3, 2, 3, 3, 3. So there's all 27 of them. Now, if you're asked to draw a sample space diagram, a lot of times they're not going to make it super huge, all right? This one's a little bit larger, all right? Need to be able to see that. Now, some of you might, with knowing what we're doing, some of you might go, well, I could have not drawn one of those columns.
Which one?
Which one could I have left off?
The last one.
The last one. Why?
Because it's automatically going to be bigger than the...
Yeah. Since the first number is the biggest it could be, there's no way for the last number to be bigger than the first number. So I could have just left all those off. I could have saved some time. I know there's 9 there, but I don't really need to not write them down because I'm not going to have any answers over here. All right? Now, if I go look at the rest of this, all right? If I look at this column here, where is my last number bigger than the first 2 numbers? Now, not added together, just bigger. Well, this 3 right here is bigger than the 1. It's bigger than the 2. So that's one of the examples that I want. Okay? This 3 right here is bigger than the 2, and it's bigger than the 2. So I want that selection. All right? Is there any other ones in the middle? That 3 right there, I might look at that, but I can't use that because that 3 is not bigger than it. Okay? So now let's go to the first column. Which one would work in the first column?
The second one?
The second one, this 2 is bigger than both ones. That 3 is bigger than both ones. That 3 is bigger than both of those. How about this one right here? No, because the 3 is the same. Okay? So how many do I have that work? I have 5 of them that work. Okay? 5 of them that work out of the 27. So my probability here would be 5 out of 27. Okay? Now, a sample space diagram, drawing out all those possibilities was about the only way that I could really do this one. It would have been very difficult to think through all that and try to do that. You might, all right? But by the time you think through it, you might have better efficiency just writing it all down. Okay? Everybody okay on that one? Now there's other things I could ask about that question as well, but that's the one that they asked.
There's no way to like calculate it?
Huh?
There's no way to like calculate it?
There's not a way to like do any math to do it. We have to really see it, all right, on that one. Okay? All right, another sample space diagram that's very common to a lot of us would be if I were to roll 2 die. So if I'm playing Monopoly or something like that, and I'm rolling 2 die, and I'm taking the 2 die and I'm adding them together, so that tells me how many moves or how many spaces I'm going to move. All right? So if I were to do this, I'm going to add all this up. So 1 plus 1 is 2. That would be 3. That would be 4, 5, 6, 7. The pattern goes through all this as we're going. So this would be 3, 4, 5, 6, 7, 8. This would be 4, 5, 6, 7, 8, 9. Now, you don't have to fill it out the way I'm doing it. You can do it another way, all right? You can do vertically. I don't care, all right? But we just need to be able to get this all filled in. Okay. Again, this is a very common one. This is a very common sample space that they like to ask about. Okay. I've seen this one on the actual test before. They didn't put the numbers in it. They just put dots where there was an answer, so you could see how many was in the sample space, and you can go from there. Okay. By the way, if I'm rolling 2 die, could you tell me how many is in the sample space without having to draw it all out? There's 36 because there's 6 spots on this one, and there's 6 spots on this one, so 6 times 6 would be 36. Okay? Let's answer a couple questions here. So the first question, it says, what's the probability of throwing the sum of 6? Okay? So what's the possibility of throwing the sum of 6? Well, how many 6s do I have in my sample space?
5.
I have 5 of them. Okay? I have this right here, there, and there. Now, some of you may argue, no, there's not 5 of those, especially if you were to take a pair of die and you had both white die and you don't have like one's different than the other. But if I have it like I have here, if I have a red and a green one, if I were to roll a 5 on that one and I were to roll a 1 on that one and get 6 that way, so you have that picture, versus if I were to roll a 1 on this one, or excuse me, a 5 on that one and a 1 on that one, now that's actually different, correct? You're going, no, there's still a 1 and a 5, but they're 2 different ones because the 1's on dice A and the 5's on dice B. So this 1-5 is actually different than that 1-5. Make sense? It's a little bit easier to see when they're different colors. When they're the same white colored die, it's not as easy to see. All right? So that's the case. So 5 out of 36 would be the answer for that one. Okay? How about the next one? What is the probability of throwing the same 2 numbers? What do we call those? Doubles. Snake eyes is one of them. All right. Snake eyes, boxcars. All right. We're rolling doubles. How many doubles do I have?
6.
I have 6 doubles. Where are they?
One in each row, right? They all like to be.
Oh, no, yeah, they're like in a diagonal line.
They're on that diagonal. I got 1-1. I got 2-2. I got 3-3. I got 4-4. Got 5-5. Got 6-6. Okay. So I have 6 out of the 36. So 6 out of 36. What is that?
1-6.
Okay, 1-6. All right. Now, think of it this way. All right. Or what do you think? Is 1-6? Does that seem too high, too low, or does that seem right? Thoughts on that?
Seems kind of.
Seems kind of high.
Seems right. Seems kind of high. Okay? Now, I play, when I play games sometimes with my kiddos at the house, I have one child that will take and she will roll a die. She goes, there it is, right? And now she's gonna try to match this one to whatever she needs with that, right? Well, if I have a number on that one, how many of them match here to make it a double? 1 out of the 6 here match that one to make a double, correct? Make sense? So that kind of makes sense with what's going on there. Good? All right. Last one. By the way, could you have thought through these two and maybe not drawn the sample space diagram?
Yeah.
Maybe so. But how about this last one? How many of them are less than 6? There's 10 of them that are less than 6. That's correct. All right. Where are they? Well, all the 5s, all the 4s, all the 3s, all the 2s. So it's a little bit easier when I can see them all right here, and I can go. So there's 10 numbers there that are all less than 6. So 10 out of the 36, or you could say 5 out of 18. Okay? Everybody good there? That is where we're going to stop today. That's all we're doing today. All right, so it's a quick, little, easy lesson today. Here's what I'd like to do, though. All right, we're going to add one page to, so the page 373. All right, 373, that sample space diagram is what we just did. So I'll stamp that tomorrow with 368, 370, 371, 373.
Wait, is it all of it or just?
Yeah, do the 4 there. There's just 4, okay? All right, you have 10 minutes. You can work, all right? You got 10 minutes to work.
Wait, so 373 as well?
Yes, add 370.